Hello, everyone, and thank you for attending this introduction to wetlands in Sherburne County. My name is David Wick, and today I will be joined by Matt Dansel from Sherburne County Planning and Zoning to discuss wetlands with you. So, without further ado, let's get into a brief overview of what we're going to cover, and then let's get into things. So, brief overview of what we're going to do. We're going to start with some introductions, then we're going to cover why, as human beings, wetlands are important to us. Then we'll go over the Wetland Conservation Act of Minnesota, the three parameters of what a wetland is. Then we're going to look at some different wetland types, and finally finish things off by walking through a couple of example scenarios. So, my name is David Wick. I'm a resource conservationist here at the Sherburne SWCD. Been here about 5 years now, and I work with landowners on forestry and wetland-related concerns and projects. So I'm also a member of the technical evaluation panel, which we also call TEP, that reviews all of the wetland-related permits and decisions within the county. Matt?
Yeah, hi, thanks. Matt Danzel. I'm the water resource planner for Sherburne County Planning and Zoning. I handle wetland permitting and review in the areas of the county that are not within a city boundary, so all the unincorporated areas, and then also the city of Princeton and St. Cloud within Sherburne County. I started the county last May, but I do have about 10 years prior wetland regulatory experience.
Thanks, Matt. So let's start by talking about wetlands and why we care about them. So basically, what do we gain from wetlands? So starting off, wetlands serve as a critical fishery habitat. Specifically, they act as nurseries for many fish species, providing shelter, food, and breeding grounds. So some of your game species, like walleye and bass, they don't necessarily spawn in the wetlands, but many, if not all of the fish that they feed on spawn in the wetlands. So thinking about Sherburne County, some of the lakes within the county, the first lake that comes to mind that has these wetland complexes surrounding the lake is Lake Fremont up in Zimmerman. There are multiple wetland complexes surrounding the lake. Not entirely, there is still that urban aspect of it as well. But the fish have actually been tracked to travel through culverts into connected wetlands to spawn, and then we track them back, returning to the lake to continue the rest of their life cycle. So a very cool example, even within the county, of these fish species using these wetlands to spawn. Next up, wetlands are essential for wildlife habitat. They provide food and water and shelter to an extremely diverse group of birds, mammals, reptiles, and amphibians. Many rare and endangered species rely on wetlands for their survival, which makes wetlands an essential ecosystem for biodiversity conservation. Wetland plants also support pollinator habitat. Flowering plants in wetlands attract bees, butterflies, and other pollinators, which are vital for the reproduction of many plants, which also includes crops. So wetlands are also indirectly important to food production. And finally, recreation. Wetlands offer immense value recreationally. They're popular for bird watching, photography, hiking, fishing, hunting, and even kayaking if they're deep enough. And personally speaking, I can tell you that one of my favorite hunting spots is Lowland Tamarack Bog, just kind of west of here. I don't know about you, Matt. What was your last recreational activity you've done in or near a wetland?
Yeah, so I'm a hunter as well, and took my son out duck hunting and had a great time. I had a lot of red-winged blackbirds chirping at us, so yeah.
Thanks. Moving along here. So I initially tried to split wetland functions and values into two groups. So the values that as an individual we benefit from, but now let's also talk about the benefits that the entire community benefits from. So wetlands play a critical role in groundwater recharge. Wetlands act as a natural sponge, absorbing the water and allowing it to slowly percolate into the aquifers. Through this water movement, essential irrigation water is replenished, especially here in Sherburne County. We see so many center pivots that are actively irrigating most of that growing season. But because wetlands kind of act as that natural sponge, they also act as a bit of a natural water filter. As that water flows through the wetland, plants and soil trap pollutants, sediments, and other excess nutrients like nitrogen and phosphorus. This, quote unquote, filtration process improves water quality, which benefits both humans and the animal populations that are using this water. Wetlands also act as a natural buffer, stabilizing soil with their dense root systems and reducing the impact of waves in lakes or the impact of currents in rivers. So when we remove these wetlands, we're actually setting ourselves up to start losing the lands that those wetlands are actively protecting. Not only are they a natural buffer, they also help with flood attenuation. So what we're saying by flood attenuation is that's the reduction of flood peaks. So that's what that graph is demonstrating. When we remove all of the wetlands, we start to see that post-development. And then when we add wetlands back in, or pre the removal of wetlands, we see more of that pre-development curve. Wetlands are able to do this by slowing down the movement of water. They hold it, and then they gradually release that water either on the surface as surface water flows or into the groundwater as groundwater reflows. So this reduces the intensity of floods and protects communities and infrastructure from flood damage. And then finally, wetlands are extremely good at stormwater retention. So in urban areas where we have a lot of impervious surfaces, roads, buildings, and whatnot, that prevent water from soaking into the ground, wetlands intercept and store that stormwater runoff. So this reduces the risk of urban flooding and helps filter out pollutants before they reach the larger water bodies. So an example of this is, as an engineered practice, is rain gardens. We're trying to simulate that same benefit that we would get from the wetlands, so the water storage, that slow release of water, and also that filtering of pollutants. And we're trying to do that in an urban landscape. So that's our solution is rain gardens. So hopefully now you have a slightly deeper understanding of wetland functions and values. So let's talk about the Wetland Conservation Act.
Yeah, so why am I here talking about wetlands? Well, it's because of the Wetland Conservation Act and wetland regulation. So the Wetland Conservation Act was enacted in 91. There's been rule changes and updates and statute changes since then, but basically the goals have remained the same. No net loss of the quantity, quality, or biological diversity of wetlands, avoiding direct and indirect impacts to wetlands, and then protecting and preserving and restoring wetlands that have been drained or diminished in some way. And wetlands are, in Sherburne County, wetlands that might be impacted need to get a permit. So if you want to do a project near in a wetland, you might need to get a permit through us. So wetlands can either qualify for an exemption, or if they don't qualify for one of these exemptions, such as de minimis, they might qualify for a replacement plan where you would have to mitigate wetlands. Sometimes they can be confusing in where they are in the landscape and how to identify them. But we'll talk about a couple of the definitions here first. So there's a legal definition in the Wetland Conservation Act rules, and then there's a federal definition there to compare. They're pretty similar. They both talk about having hydrophytic wetland vegetation. So those are wetland plants that have adapted to grow in saturated and wet soils. Wetlands need to have a hydric soil component, so soils that are they have special biochemistry and how they've been adapted to support wetland vegetation. And then hydrology, of course, is what drives wetlands, is the water, how it's moves through the landscape and the soils, and how frequent and the water is making the soil saturated or ponded. I think David will get into more details of those coming up.
Awesome, thanks, Matt. So now that we've kind of covered, the three parameters of a wetland, so that that vegetation, that soil, and that hydrology, let's break those down and get a little bit deeper. So during the growing season, vegetation is usually the first thing that we look at to determine, are we in a wetland or are we not in a wetland? And Minnesota is broken down into 3 land resource regions, which kind of help to provide context for wetland delineation by highlighting the different influences that climate, soil, and land use have on wetland characteristics. So here in Sherburne County, we sit on the border of the northern Lake State Forest and Forage region, which we call the northern region, and then the central feed, grains, and livestock region, which we refer to as the central region. And each plant that can be found in these regions is assigned a value for how often it's found within a wetland. So the reason that these different regions are significant is because the frequency that a plant can be found in a wetland can change between these land resource regions. So, for example, the quaking aspen, an iconic tree that many of you are probably familiar with. The quaking aspen in the central region is considered facultative. This means that it's equally as likely to occur in an upland as it is a wetland. However, once we reach that northern region, the quaking aspen is actually considered facultative upland, meaning it occurs in an upland or a non-wetland area 67 to about 99% of the time. So these facultative and facultative upland are 2 of the 5 ratings that we have. We also have facultative wet, meaning those plants occur in a wetland 67 to 99% of the time. And then we also have our obligate wetland and our obligate upland species. So obligate wetland and obligate upland mean the vegetation occur almost always in either in that upland or in that wetland environment. I would say the vegetation occurs 100% of the time in either one of those particular environments, but nature doesn't always work that way. It doesn't always follow the rules we want them to. So I'm never going to use absolutes when it comes to nature, but the predominant vegetation is in that obligate upland or obligate wetland is going to be either upland or wetland. I also want to touch on the significance of some of the wetland plants that we see out there. Earlier, I was talking about wetland functions and values. So we talked about how wetlands act as this natural sponge, this natural filter, and how wetlands can be responsible for absorbing nitrogen and phosphorus. So there are a handful of plants that excel at nitrogen absorption, including cattails, phragmites, also known as common reed, bulrush, and water lettuce, just to name a few. So cattails are probably one of the most common wetland plants that people are familiar with. So here in Minnesota, we actually have a native cattail and a non-native cattail, and they can be extremely difficult to differentiate just on their own, let alone the fact that they're also able to interbreed, and they've created this extremely aggressive hybrid cattail. So cattails are one of the best at absorbing excess nutrients like nitrogen and phosphorus from the water and the soil that they're in, but unfortunately, because of their invasive nature, they also can create some ecological issues due to the fact that they form these dense monocultures compared to more diverse plant species, which make up a much more ecologically beneficial habitat. Next up, let's chat about soils. So wetland soils are also known as hydric soils, as Matt mentioned earlier. Hydric soils form under conditions of saturation, flooding, or prolonged or ponding long enough during the growing season to create these oxygen-depleted environments. Hydric soils are influenced by the state's varied climate, geology, and topography. For example, in the forested regions up north, wetlands have organic soils like peat or muck. We see the same soils down here in Sherburne County, typically in a tamarack bog. Peat as a soil is dark brown to black and is formed from the partial decomposition of plant material in an oxygen-poor environment. So peat is a very, very distinct soil type, has a very distinct temperature or texture, and it's also much lighter in weight than a sandy or a clayey type soil. So you can physically feel the difference in some of these wetland soils compared to some of our upland soils. And then when we are trying to determine whether we're in a wetland or we're not, soils are one of our longest lasting clues as to what the land was. And what I mean by this is that you can install a ditch or you can install tile, and that's going to remove the hydrology, so the water, or you can cut down all the vegetation, removing the vegetation, but our soils are going to remain pretty much the same. And the reason for this is that soils take so long to form, so it also takes them just as long for them to change their characteristics from a hydric soil to a non-hydric soil. But remember that we need to have all three parameters. So just because we have the soils doesn't mean we're in a wetland, but it does give us some clues to determine, are we in a wetland or not? And when we're looking at the soils, one of the things we look at, or one of the major components that we're looking at, is the color of the soil. So that photo on the bottom right is called a Munsell color book. So each color is assigned a chroma and a value number associated with it. And then we use these numbers to give the soil an official color. As you can see in the photos, the soil color changes as we go downwards in the soil profile. We break that soil profile into layers, and then we assign a color value to each one of those layers within the soil. Then, based off guidelines set by the state, we look at the soil color, the size of the layer, the texture, the hydrology, reductions or concentrations within the soil. And all of those factors together are able to help determine whether that soil meets the hydric soil requirements. So now that we've got vegetation and soils, next up is hydrology. So hydrology is influenced by a number of factors, obviously including precipitation and snowmelt, but also what our groundwater levels are and what surface water flows are. So all of these contribute to the presence, duration, and frequency of water within a wetland. When we're in the field assessing hydrology, some of the indicators that we are looking for are obviously standing water, but also watermarks on vegetation or debris. These debris are very common. The watermarks or the vegetation or debris are very common in riverine wetlands where we have this flowing water. That flowing water can pick up vegetation or the debris and deposit it against the sides of trees or signs and whatnot. And as that water level goes down, typically that debris stays at the same elevation as when it was deposited. Or we're able to see lines of dirty soil or clean soil. And all of those give us clues as to what the hydrology was previously. But not only are we looking for things above the soil surface, we're also looking where soil saturation occurs within that soil profile that we just talked about. So not all wetlands have standing water all 365 days of the year. So depending on the month's previous precipitation, kind of determines the factors for how wet or dry we expect our wetlands to be. So in order to determine that previous month's precipitation, the Army Corps of Engineers created a tool that gathers data from weather stations in an area and creates this great graph that you see on the screen. So the blue line is the 30-day rolling precipitation total, and the orange area is the 30-year normal range. So as that blue line goes above the orange, we can assume that conditions will be wetter than usual. And if that line starts to drop below the orange, we can assume conditions are slightly drier than usual. As you might be able to see in that bottom box, the far right-hand corner, the tool assigns a value based on the conditions, and it spits out a different value telling us how wet or dry the conditions are. So what our the difference between where we're currently at and what is considered normal. And this just helps us guide decisions in the field when we're looking at these hydrology levels. If we're kind of right on the edge of one factor or another and we're overly wet or overly dry, it can sometimes help guide whether we should push into one region or another. So I've given you a bit of a brief overview into all three of the parameters, so hopefully you understand a little bit better all of the factors that go into deciding whether a wetland is present or not. So now I'm going to hand it back over to Matt, and let's talk about, do you have a wetland on your property?
Yeah, thanks, David. So as David mentioned, the three-parameter approach is used to identify wetlands, and you might be asking, well, how do I know if I have a wetland on my property? So the way to know for sure is to you have to hire a wetland professional, which in Minnesota is called a certified Minnesota wetland professional. They perform a wetland delineation. So there's the science that David just mentioned is applied on the ground to determine if those three parameters are present. There are some tools out there that you can use, before hiring a delineator or things like that to get a general sense of where wetlands might be on your property. There's something called the National Wetlands Inventory, or NWI, which is shown here in this figure. The green and yellow polygons on the screen there identify where it's likely that wetlands exist. Those were developed, through aerial photography and elevation data at a national scale. So kind of big picture. So it's not 100% accurate, but it gives us a good sense of where wetlands could be on the property. The other tool is the web soil survey. And so there is a survey done on all the different counties, and it shows where different types of soils are on the landscape. And you can identify if you might have a hydric soil that's been mapped by the web soil survey. And that can give you some clues as if you're in potentially a hydric soil location or not. And there's kind of a gradient of how hydric the soils are, if they're 100%, all the way down to just a few percent hydric. So it'll give you that information. So once we've identified the wetlands on the property, then we need to kind of tell what type they are. And in the Wetland Conservation Act rules, there are different types of wetlands that are regulated differently. So they range from being very shallow, seasonally flooded, not having a lot of hydrology would be your type ones. And then you get more hydrology as you go higher in number, generally speaking. So your type 2 wet meadows are more saturated. It doesn't have to be throughout the whole year, but at least generally about 14 days or a few weeks out of the year, it's saturated 12 inches to the surface. Shallow marsh wetlands are, a lot of people are familiar with these. They have 0 to 6 inches of standing water, and generally, you'll see cattail fringes. Those are generally shallow marsh wetlands. As you get deeper, it'll go from 6 inches to 3 feet. Then you're in a deep marsh, a type 4 wetland. And then even deeper is the shallow open water. Shrub swamps, type 6, they can have alder, willows, dogwood species. Those generally have some standing water at the surface, but it's not, it's only, a few inches to 6 inches, and it can fluctuate throughout the year. Wooded swamps, those generally have elm, black ash species, and they can be pretty saturated soils throughout the year. And then your bogs, tamarack bogs, they can have floating sphagnum moss in them, and they're generally have hydrology throughout the year as well.
Thanks, Matt. So now that he's kind of gone over all of the different types of wetlands, the type for you in most cases doesn't really matter. But let's go over what these actually look like when you're seeing them in the field. So I figured we should start with some obvious wetlands that you all can probably see, and they're very recognizable to you. So what you're seeing here is you're seeing open water. You see the cattails, the wetland edge. It might actually extend a little bit further than you're aware. Um, but overall, these wetlands that you're seeing in these pictures they're pretty obvious. So the right is actually pretty similar to the picture on the left. It has that standing water, but it has a slightly different plant community and definitely a different time of the year for the pictures. But I would say the majority of people here would agree that this is a wetland. However, most people don't realize the true extent of the wetland, and that's kind of where that professional wetland delineator comes in. So the wetland doesn't necessarily end where that standing water ends. So as Matt was kind of talking about that type 2, it doesn't necessarily have standing water. It might just have saturated soil for a certain number of days during the growing season. So those fringes of the wetlands, they have that hydrology in the top 12 inches of soil. So they might also qualify as the wetland. So finding and determining the edge of that wetland is just as important as identifying that you have a wetland, especially when you're doing any sort of work nearby or it potentially could impact that wetland. So that's our obvious wetland. Let's go to a less obvious wetland. So this is one of my favorite types of wetland, and that's the seasonally flooded wetland. We also refer to these as vernal pools or ephemeral ponds. While they may be one of my favorites, they're also one of the hardest to identify, especially when they're not full of water. So these wetlands are typically inundated during the spring, and then over the course of the summer, they dry up, and it can be completely dry by as soon as late August or late July or early August. So these are extremely important habitats for dragonflies, turtles, salamanders, frogs, newts, and just various other insect and animal species. One species that I just recently learned about was the fairy shrimp, and that only lives in these vernal pools, and they hatch from an egg in the early spring when that water is high. Then they reproduce, lay eggs before the water dries up in the fall, and the eggs overwinter in the sediment. And then every year that process repeats itself. All this is saying is that these are extremely unique wetland species which support a massive, massive variety of different species, and they can be absolutely fascinating to look at throughout the growing season if you have one on your property. Next up, we have wet meadows. And from a regulatory standpoint, these are the wetlands that are most difficult for landowners to identify, just due to the fact that there usually isn't standing water. And many times during dry years especially, these can appear to be an upland habitat. In agricultural settings, these may have been regularly grazed or hayed in drier years. And in these wet meadows, with appropriate soil and climatic conditions, you might only observe soil saturation at 8 or 10 inches down into that soil profile. However, the vegetation and the soils will still display wetland characteristics, and there are specific guidelines for looking at hydrology during the growing season or the dry season or the non-growing season. So wet meadows are a host. They host a massive variety of rare flowers and plants, and these flowers and plants also support pollinators and other beneficial insects. But as you can see in the photos on the screen, the vegetation can vary widely. That bottom picture is a reed canary dominated wetland, and these are the wetlands that landowners typically get themselves in the most trouble with. It looks like a grass field. This was more than likely either hayed or grazed in the past, and because of that land use, people anticipate them to be upland habitats, when in reality, they do meet the criteria for a wetland. So these can be very frustrating and difficult to work with, but they are an essential part of our ecosystem, providing all the same wetland values and benefits that I discussed earlier. And finally, the floodplain wetlands. These are very noticeable when they're wet and a lot less noticeable once those floodwaters have started to recede. Floodplains are really essential for both flood control and water quality because that floodplain area allows the water to spread out and slow down, especially versus a more channelized river, which creates those faster flows and throughs for the water, which lead to surges and pulses and make systems more prone to flash flooding. Also, by allowing that water to spread out over a larger area, it slows the water down and it allows sediment and nutrients the opportunity to settle out of the water, making the water cleaner as it flows downriver. So during the dry season, floodplains can appear as uplands, but there are kind of a few distinct characteristics that help us differentiate whether it's an upland or a floodplain. So that picture on the top left does a really good job of demonstrating a sparsely vegetated understory, and this is due to the inundation, so that frequent flooding. In the picture on the left, it's very obvious. There's no herbaceous layer underneath that tree canopy. You also might be able to see some water lines on the trees. So the change in color at the base of the tree is a great clue that there was a regular hydrology pattern going through this area. You also won't find species that are 100% upland species in these floodplain wetlands because of that hydrology aspect. Instead, you're going to find more of your wetland species. You're going to find your willows or your cottonwoods. And those are the plant communities that are going to make up more of these floodplain forests. And then finally, the most obvious is they're going to be adjacent to or within the flow path of water. So if you're not within the flow path of water, you can't have a floodplain wetland. Moving on, Matt's going to talk about what you can do if you suspect you have a wetland.
Yeah, so we talked about identifying wetlands on the landscape, on your property. And so now the next step is, well, what can I do now that I found out my wetlands, where they are? So the Wetland Conservation Act, it regulates wetlands, but there's certain things that aren't regulated, such as normal agricultural activities. So your normal seeding and tilling, things of that, are not regulated as long as they don't cause a drainage to the wetland. You can mow. Vegetation removal is not regulated, so you would be able to mow wetlands if you if it happens to be a drier time of the year and you want to walk through it, you can mow paths, as long as you're not creating deep ruts and things like that. That could be when you start disturbing the soil. That's kind of where it could start triggering some regulation. You can install fences and posts. Those are not considered fill within wetlands. And then you can do some habitat improvements. And of course, you can recreate in wetlands. So now you might be asking, well, if I want to do something, what do I need? And do I need a wetland permit? In Sherburne County, most activities, if you're going to be impacting a wetland, you do need a permit in Sherburne County. And so an impact is defined as draining, filling, and sometimes excavation in certain wetland types. And so sometimes what you want to do could qualify for what's called like a de minimis exemption. It allows a certain amount of impact to wetlands without having to do mitigation or replacement. Installing culverts and, like I mentioned, excavating and digging in some wetlands can qualify for a no loss activity. So you would need a permit for all those activities, but you might not need to do any mitigation. Of course, recreation is, you don't need a permit to use your wetland. And as I mentioned, vegetation removal, like mowing, wouldn't need a permit, but depending on where you are, such as in a shoreland situation, it might need a shoreland permit.
Thanks, Matt. So now I figured we should run through some scenarios to kind of put everything, all the book learning onto the ground and kind of see where it lands and how this all shakes out. So I came up with 2 scenarios that kind of encapsulate some situations that we've seen in the past and kind of give people an idea of what is or isn't allowed in or around wetlands. So in this example, a landowner owns a property outside of the shoreline district, and they've been putting their grass clippings and branches from their yards, placing them from the upland, taking them from the upland and placing them onto the edge and into the wetland basin itself. So the amount of material that they're putting within the wetland boundary is less than the allowed de minimis for the property. So Matt, is the landowner in violation of the Wetland Conservation Act?
So if it's under de minimis, they likely would not be in violation of the Wetland Conservation Act. But yes, they would probably need a permit. And so that de minimis amount that we mentioned can vary widely depending on your wetland type, and especially if you're in a shoreland zone. So if this, even though it might be a small amount of fill, there's certain areas within shoreland zone that you might only be allowed to impact 100 square feet of a wetland, which isn't much. So that's why we we permit those activities to make sure they comply.
Absolutely. And I think it's also important to note that we do keep track of de minimis. So if you use your de minimis in 2024, you might not be able to use it in 2025. Moving along, scenario number 2, a landowner owns a 40-acre parcel that contains upland and lowland areas. They have mowed trails through both the upland and the lowland areas. Is this landowner in violation of the Wetland Conservation Act?
So, yeah, mowing trails, not regulated as we mentioned, as long as you're not using the bucket there to push the soil around and things like that. Just the mowing is okay, and we do not require permits for mowing trails through your wetland or removing vegetation, as long as there's not piling of the vegetation and things like that within the wetland.
And would they need a permit to do that mowing, or as long as they're not piling the vegetation? It sounds like no permit would be needed for that, right?
Yeah, correct. Like we mentioned, maybe if you're in a shoreland zone situation, there might be more regulation with that, the shoreline zoning.
Okay, and let's expand on this scenario a little bit. And let's say that landowner wants to put some fill into some of these lowland areas so they can, drive their ATV around the whole property, go get that big buck out of the back 40, a little bit better access. Can they do that, via the Wetland Conservation Act in Sherburne County?
Yeah, I mean, it's possible, but it would require a permit. So we would need to have a permit or an application submitted, and we review it to make sure we're falling under those exempt criteria or no loss criteria. Otherwise, it could be in violation and then potentially need mitigation.
Thanks, Matt. So thanks for joining us today. If you guys have any questions or you're looking to get a permit, please contact Matt with permit-related questions, or feel free to contact myself with any wetland restoration-related questions. So otherwise, have a good day, and thanks for joining us.
Thanks.